Hello and welcome to my question walkthrough of some Gauss's laws and Ampere's laws questions for electromagnetism. Let's have a look at the first question. Here we have what will be a Gauss's law question. It asks us to determine the electric field due to an infinitely thin 1D wire with linear charge density of lambda. Now, I like to draw a diagram. So here we have our wire, and we have a Gaussian surface that surrounds the wire. This will be a cylinder with radius r and length L. Now, the electric field coming off the wire will only penetrate out through the sides of the cylinder. It won't go out of the top or the bottom because it is infinitely long. So we now need to look at Gauss's law, which says that the closed surface integral of the electric field equals the charge enclosed divided by epsilon naught. Now, our surface is 2 pi RL, which comes from the outside face of the cylinder, and we can simply put it in like this and say that E 2 pi RL equals Q over epsilon naught. Now, Q is our charge, and we have charge density. Now, charge density is charge per unit length, and simply rearranging this, we get our charge to equal lambda L. So if we put this into the equation, we get E 2 pi RL equals lambda L over epsilon naught. This can be simply rearranged, and then we cancel the L's from both sides to get our electric field of E equals lambda over 2 pi R epsilon naught. Here we have a question that asks us to determine the electric field E due to an infinitely thin 2D plane with uniform charge density sigma. Here is our infinite thin plane, and here is our charge density sigma. We'll be looking at this section of the plane in the middle, which has a Gaussian surface above and below of it, with area A and area A. The electric field will be passing out through these surfaces only, so this is where we apply our Gaussian law. Here is Gauss's law. Again, the closed surface integral of the electric field equals the charge enclosed divided by epsilon naught. Now here our surface is 2A, 1A above and 1A below, and we sub it in just like before. E2A equals Q over epsilon naught. Now, our charge density is charge per unit area, which can be rearranged to equal charge equals charge density times by area. And we can sub this into our equation to get E2A equals sigma A divided by epsilon naught. Now, rearranging this and cancelling out the A's, we get our solution E equals sigma over 2 epsilon naught. Here we have a question that asks us to determine the magnetic field B due to an infinitely thin wire with constant current I. This is our infinitely thin wire, and this is the constant current traveling down it. Now, the current traveling down the wire induces a magnetic field that loops around the wire. And to find out what this magnetic field is, we have to use Ampere's law, which says that the closed line integral about a magnetic field is equal to mu naught times by I. Now, we need to integrate around the circle being the loop of the magnetic field. And this means our Ampere's law equals B times 2 pi r, as 2 pi r is the circumference of the circle. And this equals mu naught I, which can simply be rearranged into B equals mu naught I over 2 pi r. And this is our answer. Thank you very much for watching this video. I hope it has made these Gauss's laws and Ampere's laws a bit clearer. If you've spotted any mistakes that I've made, please let me know and I will try and correct them as soon as possible. Thank you very much.